I was talking about this. So turbine mechanical power versus wind speed curve. So here you can see it, how much is power and how much is speed. So in this right side figure, you can see it. It is a speed. Wind speed is there, cut in, rated, cut out, and on y-axis you can see it, power is drawn. So here what is happening is initially no power is there. You can see it graph in power, no power is showing. Means initially if the wind speed is lesser than some speed, means it wind turbine will not be able to generate any power. For example, you can take it for most of the practical cases, it is 2 meter, 2.5 meter, or 3 meter per second. So if it is like, for example, if it is cut-in wind speed is 2 meter per second, then if wind speed is less than 2 meter per second, wind turbine will not be able to generate any power output. So in some cases, whether it can rotate also or not rotate also, whether it is blade is rotating or not, but it will not be generating any power. So in these cases, whatever is generated power, it will not be able to overcome the losses in the system. So that's why power will be zero only. So once the cut-in wind speed is achieved, like for example, if 3 meter per second is the cut-in wind speed, once it is achieved, then only we will have some power generation from the wind turbine. Then the power generation from wind turbine, yeah. So then the power generation from wind turbines, it is generally increasing with the speed in wind speeds. As the wind speed is increasing, the power output from the turbine will be increasing, and it is power cube. So if velocity is wind speed is getting doubled, the power will become 8 times. So like that, you can see the graph is increasing very exponentially. It is increasing. Then at a rated wind speed. So each turbine has some rated wind speed. Some has 11 meter per second, 12 meter per second, or 17 meter per second. So it is, so the turbine has one rated wind speed. Once it is achieving rated wind speed, so at that rating, then after that the power output again it will not increase. Like if the turbine rating is 1 kilowatt or 1 megawatt. So for example, if the turbine is rating, wind turbine is of 1 kilowatt, then if the wind speed is further increasing also, it will be only generating 1 kilowatt only. It will not generate more than that. So you can see the curve is flat after that. So if the wind speed is increasing from rated, say it is 12 meter per second, from that some speed, say 20 meter per second or 25 meter per second. So on that, the power output will be same. So if turbine is 1 kilowatt, it will be generating 1 kilowatt. Then more than 25 meter per second, if wind is coming, then again it is crossing the cutout wind speed. Then after that also, it will not be generating. The turbine will go in parking mode. It is because safety is required. For the wind turbines, you see they have large number of bigger structures. So if wind turbine is, if wind is coming very high, like cyclone or some other cases is coming, then what will happen? Turbine will fall, and then safety issue will come. So because of that, parking mode is there. Then after that, we should not use the wind turbines. Generally, for safety issues, turbine will get locked. So that's why we don't have any generation after that. And left side you can see it MPP. So MPP is maximum power point tracking. Maximum power point tracking is like extracting the maximum power. So it will have generally both mechanical and electrical trackings. So mechanical, uh, uh, in electrical tracking, what we do is based on the impedance matching, the maximum power point tracking will happen. So that the generated energy should be maximum generated energy should be extracted by matching the impedance in both the sides. Then here you can see it, wind energy systems. It is also like earlier I have shown, solar is both types, grid connected or a standalone. A standalone is not connected with grid, and grid connected is on which the output is connected with the grid. So generally you can see, here you can see it, main components of wind energy conversion systems. So Here when it is a power conversion. So here you can see it for grid connected system how like power conversion. So mechanical power, it is through gearbox generator. Then the power is generated. Once from generator power is generated, then we'll be having power converters, transformers, and then it will be given to the grid. So before giving to the grid, we require the power should be within the standards. The voltage, the power quality should be within the requirement. Voltage and current level should be as per our requirements. Like you see the what we get the power from the supply is around 230 volt, and frequency 50 hertz. So whatever power is generated from wind, it should also match with what the power available from grid. Like in grid, the already power is available. It is coming from other sources. Like grid, they have different sources, like they are generating from coal or some places. So so one power we have, then another power we have from wind generation. Then both should uh, both should match. There should not be any mismatch between those. If mismatch will be there, then the safety issue will come. So and also that voltage levels, current levels, harmonics, frequency, everything should match. For that, we'll have different things like power converters, different units, transformers to boost the voltage. So after conditioning that power only, we are supplying to the grid. Then here I will show a classification of converters. So, you know that the DC-DC converters is called, generally we call as converter. For DC-DC also we required, like the generation from solar or wind, it will be having one value, like it will be having 24 volt, 40 volt. But what we require at load side will be different. Like you have seen most of the batteries which you use in home. In home also you'll be using the battery will be coming 12 volt. Then there is a requirement. Your solar or wind generation will be different, but our requirement is different. We need 12 volt. Then uh, from the generated power to convert it to bring it at a certain level, we need converters. Similarly, inverters. So mostly DC-DC converter, which example I have shown, like if it is generating 24 volt DC and our requirement is 12 volt, if we have to charge the battery of 12 volt, or we have to charge some things which is laptops or some mobile phones, or some things which have 5 volt. We need 5 volt for that. Then we need DC-DC converters. And most of the appliances which you see in home is having AC. So for that we required AC power. So from DC to AC conversion, inverters are required. So here I have shown these are the major converters and inverters which is being used. So I'll be sharing another. So here I will be just talking about few of the converters, controller strategies, and inverter. Uh, so, so first I will talk about the converters. So some of the converters, which is traditional converters. Uh, so here you can see some DC-DC converters. So left side we have renewable energy sources, and then we have traditional converters, bidirectional converter, energy storage. Bidirectional, why? Because we need both sides. If in system we have battery, then one thing is we have to charge the battery from the power generator from renewable energy sources, and other is when there is no generation, that time we can utilize the energy stored in the battery and give it to the load side. So for that we need bidirectional inverters. So here You can see the slight differences. Then uh, then this is like one of the also important converter, buck boost converter. So you know that the buck boost converter, so in buck converter is used for reducing the voltage and boost for increasing the voltage. And uh, uh, and in renewable energy systems, if we have multiple systems, then we need like multi-input converters. So if we have multi-input converters, maybe we can use it different renewable energy sources at different points, like solar at one place, wind at one place, and a common. And then so on that places we can use it multi-input converters. And how the output voltage from the multi-input converters are being controlled. So it is controlled using duty cycles, duty ratios. So here we use the switchage and generally MOSFET or other things. So there, by changing the duty ratio, we can control the voltages. So if you change the duty ratio, it will change the output voltage simply. So earlier also I have shown the multi-input converter. Like here also it is a three-port converter. So here also left side you can see it, the renewable energy sources, where the power generated from renewable energy sources can be given to three-port converter, and other is the option is energy storage, is battery. Why battery is used? Because you know that the power generated from both solar and wind is intermittent in nature. Solar also sometimes cloud comes, or like that. Sometimes it is not available, and then wind speed will be too much varying. It will be increasing, decreasing. Sometimes it will be 5 meter per second, sometimes 10. So it will be changing too much. Then if we'll not use the storage system, then powering the load will be a challenge, and getting a reliable output from the system will be challenge. So that's why most of the systems are either used in a grid connected or with battery, and not directly. Uh, so generally we don't use directly solar and load or wind and load. So always either we pump it to the grid, or we use a local storage. So in local storage battery, where we store the energy, and then again based on the our load we can utilize it. So this is one type of converter. Then here also I am showing some of the isolated and non-isolated converters. So isolated converters where we use transformer. So isolated are like more safer. So in this table you can see the efficiencies. So our converters are are very efficient. You can see it is more than 90% efficiencies. It is for the converters. So in an average, in DC to AC conversion, generally 15% power is getting lost. So that is for old like old systems. And nowadays many highly efficient converters and inverters are available in market. So here you can see some of the reported converters, which is like 94%, 97% efficient also. And similarly, it is for all categories, whether it is non-isolated converter, or it is partly isolated, or it is isolated. So in all cases, we have highly efficient converters available in market. Uh, Here also again one type of converter is flux increase multi-input converter. So here again output is, you can see it, output it can be controlled again by changing the duty ratios and other factors. Here I am showing magnetic coupled high bridge converter. Similarly, full bridge converter also. This is a 2DC chopper. It is a fundamental buck boost converter. Earlier also I have shown buck boost converter. So it is a simple basic structure. Then this is a multi-input converter. So here you can see this multi-input converters. Multi-input converters are more important, because multi-input only we can use more renewable energy sources. Like here you can see some sources V1 and V2 here. You can use more sources like solar and wind. One place you can put it solar, other place wind output. So And so multi-input converters are more important. And here output, again you can see the output from this converter. It can be changed by changing the duty ratios based on our requirement, how much power is required in other stages, like which load is connected, where the power can be given. Based on that, it can be decided. Here again you can see one type of converter. So uh, different converters have different features. So here I have listed some of the features, like converters, whether it will be used for battery charging or for uh, or isolation, which one is having soft switching or hard switching. I will not go in much details. I'll just go for next step. So now I have shown about the in converters. Another part is converter was for DC to DC conversion. So so our power was from in DC and it will be in DC only. But for inverter, for DC to AC conversion. So inverters, you see nowadays, still in our homes we have most of the systems as which need AC power supply only. Uh, Nowadays, slowly the equipments which can run on DC is increasing, but still we have more percentage of the systems which require AC power. So that's why inverters are very much important, because we have to give the power in AC only to the load. So here I will talk about some of the inverters which are used in renewable energy systems. So generally there are four types of inverters: centralized inverter, a string, multi-string, and AC module. So you will see it is the smallest and basic is AC module, which will be connected with one system. Like if you'll assume like solar panels, so one AC module will be connected with one solar panel. So the conversion will be happening there only. So solar panel will be generating DC, then that place itself it will be converting to AC, and then it will be taken to the next stage. So this is simplest conversion. So it is based on the requirement which inverter we use it, and also
Hello,
yeah.
sir. What is the difference between the centralized inverter and string inverter?
Yeah. Yeah. So in centralized, you see here down in centralized inverter, only one DC to AC conversion unit is there. So that means we are bringing like DC power from all the places. Like you will be having a big farm, on that lot of solar panels will be there, maybe 50 panels or 100 solar panels will be there. Then from all those panels will be just bringing the power at one place, DC power only. All will be connecting and DC power will be coming at one place, and then we'll be converting DC to AC. So here only one place. Yeah. Yeah. So in centralized, at only one place we are converting from DC to AC. But in AC module, at each solar module, you are converting from DC to AC. Then you are transmitting AC power. So this is difference. And a string and multi-string also you can see it. Uh, so in a string, in each string, like in each string, if you have like 50 panels, so in one string you are putting 10, another string again 10, 10, 10, 10, like that you are making 5 strings. And then the combination of 10, 10 panels. So in 5 different strings, you are first converting from DC to AC, and then you are mixing all the AC power. So, but in multi-string, you are bringing all DC and then again converting to AC. So you can see the difference from the down only. So at one place, the conversion is happening for lower power. At one place, the conversion is happening like all accumulated DC power, and then you are doing. So in both the cases, the converter or the inverter which is being used will be very much different, because each will be having different ratings. So if you'll see the one solar panel, it is coming around 75 watt, or 100 watt or 300 watt, and then you are converting. So if you are converting 300 watt from DC to AC, you need a different specification of converter inverter. But if you are bringing a large number of panels, like 50 kilowatt, so you are bringing 50 kilowatt DC at one place, and then you are converting to AC, like as in case of central inverter. So for that we need a different kind of converter, and their specification will be different, and their like safety issues and all the yeah, your voice is not that much clear. Can you just type it? I think it will be better. So the main thing you can understand is uh, in central you are bringing all DC power at one place, then converting to AC. In AC module you are converting at that source only, like one panel you are converting there itself AC, and then you are transmitting at other place. So here different type of like this again, this inverter can be transformer less or with transformer. So with transformer also it is better to use, like it is more safe. But generally if you are using with transformer, then its size will be very high, cost will be more. So there are other limitations. So it is based on the requirement. We have to choose which one we are choosing. Earlier, which I have shown a string and multi-string. So again, here also a string and multi-string technology. Then AC module, which I was showing that in last, AC module for each converter with only one solar panel, one inverter. So this kind of AC module techniques generally will be flyback inverter or flyback buck-boost inverter or two transistor flyback inverter. There are multiple categories and multiple inverters available in market, which is being used in AC module technology. So here I have listed some of the inverters which is available in market. I'm not going on details. You can just see the efficiencies here in this table. Like you can see the AC module. AC module I talked, like it is having very less power. So here you can see in this nominal power category. So it is 100, 105, 160, 110, 90. So generally AC module, it will go up to 300 or 350. It will not be much higher than that. So because it is used with only one sources, like if it is solar panel, only one solar panel, then it is like a small in size, and efficiency you can see it. Its efficiency is also more than 80%. So in most of the cases, it is more than 90% efficient. So both our converter and efficient and inverters are highly efficient, which is available in market. Uh, so there are other classification also of inverter, like whether it is single stage or it is a double stage, it is a single power processing or dual power processing based on the number of stages. So some of the inverters we have like separate units. Instead of one, we have two different units. Like in A, you can see it only one stage is there. Then in second diagram you can see it is having like two stages, one DC to DC only conversion, and then DC to AC. So if we are having more number of stages, then we have more control over the power conversion, and we can get it based on our requirement. More desired output we can get it, but the system will be little bigger in bulky in size. So it is based on the it is based on the capacitor also. So based on the decoupling capacitor also, sometimes the inverters are being classified, whether the decoupling capacitor it is in parallel with the source or it is in between the inverter stages. So you can see it in this diagram. So based on that also classification is done, and how much the capacitor value, which capacitor will be suitable for the application, it can be calculated from this formula. So here we have P is a voltage, this W grid is the frequency, then UC you can see it is the mean voltage across capacitor, and again this small UC is the amplitude of ripple. So based on this, the decoupling capacitor specification can be calculated. Here I am showing some of the some more type of inverters like line frequency transformer or high frequency transformer. So this is also the type of transformer also can be chosen based on its like requirement. So different transformers has their own size, weight, and price. So generally, the high efficient and which is having like a smaller compact transformers, but will be having more price. So we have to choose which one will be suitable. Whether we have to look for high quality power, or we have to save our uh, we have to save the money. So it is like trade-off between both quality of power and the pricing. So okay, then this one is again one type of transformer I'm showing. Then okay, this is like inverter. So inverter generally it will be of like this is classification. It is self commutated or line commutated. Then again, the inverters will be like voltage source inverter or current source inverter. So that is like two main difference. So in this diagram, I am showing this current source inverter and voltage source inverter. Which I was talking as micro inverter, that a small size. Still, that also can be classified into multiple categories. You see this micro inverter. It can be either like single stage micro inverter or double stage micro inverter. Then in single stage also we have different categories like isolated, non-isolated, flyback, boost, interleaved flyback, buck boost, boost half bridge, dual boost, current fed push pull, or in double stage micro converter also you can see the categories isolated, non-isolated, buck boost based, and here the classification which I have shown you in this slide. Next you can see the efficiencies. So I have just listed the efficiencies. So for most of the inverters which I have listed earlier, the efficiencies is again more than 90% for this micro inverters also. So it is highly efficient, and some comparison I have made that I'm not going into details. Then standards. So standards are very important when we are exporting the power to the grid, or we are using some highly sophisticated instruments. So if the power quality is not maintained, then the instrument will go bad. It will stop functioning. And if the power quality is not good and we are exporting to grid, then grid may fail. So there are standards which we have to follow it. So here you can see it, some of the standards which I have listed is like IEC 61727, IEEE 1547, IEEE 929. Like that, many standards are available in market, as which we have to follow it. And the power generated from the renewable energy sources should be within these limits. Like if you say for harmonic currents, it should be like less than. Here like you can see I have given like three different categories. One is a small systems, 10 kilowatt system, one is 30 kilowatt system, and other is less than 500 kilowatt system. So in this categories, how much is the limit for harmonic and other things? You can see the harmonic current, third to ninth harmonic should be less than 4%. 11 to 15 it should be less than 2%. 17 to 21st harmonic should be less than 1.5%. So like that, it should be within the limit. So uh, similarly, you can see it, the DC current injection. So that is very important. So DC current injection should be very less. If you are exporting to grid, then DC current injection should be less than 1%. If it is higher, means it is very risky. So you can see it in the systems. If it is 10 kilowatt system or 30 kilowatt system, it should be less than 1%. And if the system is bigger, like 500 kilowatt, then it should be less than 0.5 kilowatt. It is less than 0.5%. If it is exceeding, means it is very risky. So grid may go grid may go bad. So it should be within the limit. And frequency also, it is very important. Like you can see it, frequency, it is for different system like 10 kilowatt, it should be like within +1 or -1 hertz. Similarly, for 30 kilowatt system, it should be 59.3 to 60.5. Or it, so it should, if it is crossing from this, it is not allowed. Then here you can see the voltage also. The voltage which is being you see the voltage, sometimes voltage will be changing. So if voltage is changing, but it should within few cycles uh, it should
Sir, sir,
maintain. Yeah,
actually, Kuldeep is asking, can you
yeah.
explain DC current injection?
Yeah, DC current injection is when we are giving to grid na. So that time it is important, like DC current should not go to grid. uh, DC current, DC current should not be there, because we are only pumping AC currents. But in this different power conversion na, which we are using converter and inverter, so but we still have some DC current, some like very less DC current, but it will be present. So that will cause a problem. If that DC current is available when we are injecting the power to the grid, that will cause the problem. So that is why I'm talking the DC current injection is important. DC currents, when we are injecting the AC power to the grid, the power, if any DC current is available with that and it is going to the grid, it should be limited.
Okay,
But
sir.
it will come, because our converter and inverters are not perfect. What we are making, it will be having some it will be having some DC currents also, but it should be within limit.
Okay, sir.
And here
Sir,
you can, yeah.
Sir, we have 3 minutes only. So
Okay.
I request you
Yeah,
to.
I'll just go through quickly. So here I was talking about the voltage. So the voltage should be, you see the output from the solar or wind, and then it is coming from the converter and inverter, then the output power, but it will be changing, because our from source side it is changing, wind speed or solar radiation is changing, then this output will also change. But if we are indexing to the grid, then that case this voltage variation should not be too much. If it is varying also, then within the fraction of second, it or within few cycle, it should again maintain. Like if it is 230 volt, then it should again come back to 230. But if it is like increasing or decreasing, here you can see it, I have listed, like if it is less than 50%, or if it is less than, like in between 85% to 110%. Less than 50% means if it is 230, it will become half. So like that, if it is exceeding also within the cycles, like if it is exceeding voltage also more than 135%, then within 2 cycles it should again come back to normal. So this extender we have to follow. Then this is regarding harmonic distortion also. So it should be within 8%. So I have listed for different ranges, but it should be within 8%. There are many patents available related with the grid, with the inverter. If you can search it, maybe thousands of patents are available related with the solar inverter uh, in the uh, in the market, so that you can and see it if you are interested. Here you have listed some of the controllers which are used in inverter, like some of the names, just to say, like linear controller, non-linear controller, robust, adaptive, predictive controller, intelligent controller. So generally, these predictive intelligent controllers are the recent controllers which are more efficient, and also it uses artificial intelligence and some advanced features to control it. Here I have different kind of controllers I have listed. I will not. It is just name. I will not go in details. These are different controllers. Then I will just quickly say like which kind of like how to choose the grid tied inverters. So the choosing the inverters is based on the efficiency. Generally people will go for high efficient, but another thing is like with efficiency price will come. Then power density, it should not be having leakage current or operational installation or operational cost should be less, and it should be like galvanic isolation, anti-aliasing detection, and some ideal features. Like that are the main things, the requirements which the inverter should follow, and then only if they have that kind of installation, then only they are safe and can be used. So I will stop here itself as time is almost over. If you have any quick question, you can tell.
Sir, actually, this is last class, sir.
No, tomorrow we'll be taking one more session.
Okay, sir. Thank
Tomorrow
you. Tomorrow
we'll be having again 2 sessions.
Okay, sir. Thank you, sir.
19th.
Okay, sir. Then we don't have any question today. If anybody have question,
okay. Yeah, thank you for joining. If any questions, you just text me. I will explain that tomorrow.
Or else you can